Very good. What he says, AB square plus BC square equal to BB square plus BD square. Okay. This result looks some symmetry, right? This square plus this square equal to this plus this square. What is it like? BB and BD square. Can it be proved? Yeah, it is. It can be proved. Just draw perpendicular P to AD, draw perpendicular P to AB, perpendicular here, perpendicular here. Call them as X, Y, Z, W. Then you can take these sides like A, B, so on, and by using Pythagoras theorem, by rearranging terms, it can be easily proved. So we will not get into the proof, but there is such result. This result is known by some name. British theorem. Good. At least one student knows this. So somewhere it will be handy to you. Maybe today or during the test somewhere. Right. Then coming back next to circles. So in circle, there are British theorem, British flag theorem to be precise. Why is it called British flag theorem? Any guess? It is as simple as that. It looks like a British flag. If you remember that. Yeah. Now take circle. Next concept. Here one thing some of you may be not aware called tangent. The children who are from 8th and 9th. At this stage, you will be aware actually. If one or two don't know, what is tangent of a circle? Tangent to a circle. Yeah. Very good. So there is a circle. You have a line segment, a line touching the circle. This is called the tangent to the circle, and there are some properties related to this. This is center of the circle. This angle will be 90. There is one more property related to tangents. I can draw two tangents, right? If I take PA and BB, these two are equal. They can be proved. They will even go on this in their standard, right? There is one more theorem we learn in circles. I have a circle. I have a tangent. I have a circle and I tangent perpendicular is P of distance. Just remember this angle will be 90, angle between tangent and radius. And from P, if I can draw two tangents, then lengths are equal. This concept we are going to use today, somewhere in the problem solving. Right. Now, one more, I have a tangent. The P is the point of contact. And let us say I have a chord of the circle. Okay. So, this is the center of the circle. If I take this angle between the chord and tangent at the point of contact will be equal to this angle. This is the angle made by the same chord, let us say PQ, on the other segment of the circle. This chord divides the circle into two segments, first segment, second segment. So this side you are taking the angle with the tangent, so this can be called other segment. So this angle, these two angles are equal. What is this property called? This effect theorem. Yeah. Very good. This property is known as alternate segment theorem. This is a very useful property which is not in the syllabus actually for 10th also. But this will be very handy while doing the problem solving. This is called alternate segment theorem. Right? Yeah. Now, concurrency. The next topic concurrency. So this you may have idea. In 6th class we studied. So what is concurrency? What is, when do we say? Yeah. What you are saying is congruency. I must be concurrency. Concurrent. Yeah.
Many lines pass through a single line.
Very good. Many lines, in the sense, 3 or more lines, more than 2 lines. If they are passing through a same point, those lines are said to be concurrent. Concurrent. Have you come across this concurrency anywhere? In some plane figures, somewhere, some lines are concurrent. Very good. In a triangle, the medians are concurrent. Any other concurrence? Now altitudes will come. What next will come? Angle bisectors. What next? Perpendicular bisectors. So 4 concurrencies at least we know in a triangle, right? Now altitudes in a triangle are concurrent. We all know that. We learned from long. Did we ever prove that? No. What I am asking, how, I am not asking how to prove it. Did we prove it before any time? No. But we are using that result freely for a very long time, isn't it? As if it is our drinking glass of water. So fluently. But we never proved it, right? And you know, if you want to prove 2 segments are equal, there is some way to prove. We have Pythagoras theorem, or lengths are equal, congruencies are there. But how to prove? The lines are concurrent. They are passing through a given point. That will not be that simple. That's the reason we did not prove till now, probably. And today we are going to do that. That's the first point of today's our class. So how to prove lines are concurrent? So to prove this, there is a theorem that comes very handy to prove the concurrence. That is called Seva's theorem. Seva's theorem. One boy was mentioning this already. Nice, you know it. Seva's theorem. Okay. So before we learn what is Seva's theorem, let us see what is a Sevian. There is something called Sevian. Anyone knows? You know what is Sevian?
Any line passing from one basis.
Very good. So if you take a triangle, let us say triangle ABC, I take a line that passes through the vertex of the triangle and the point lies on the opposite side. This is called a Sevian. This is called a Sevian. So in a triangle, if you take altitude, it can be a Sevian. What about median? Sevian. And what is another Sevian? Angle bisector can be taken as Sevian. There is one more. Perpendicular bisector of side. Can it be taken as Sevian? Yes or no? Huh?
Sometimes
Maybe yes, maybe no. But in general, no. Like we have to see in general. Some specific cases, maybe yes. But in general, right bisector cannot be a Sevian. By the way, if someone is wondering what is right bisector, you draw perpendicular bisector of the side. This is right bisector. It may be passing through, may not be passing through. That's why in general, this cannot be a Sevian. Right? So, what does this Seva's theorem says? I have a triangle. I have 3 Sevians. Just some 3 lines or line segments passing through vertex and the other point lies on the opposite side. These are Sevians. We are not specific here whether it is altitude, median, angle bisector. That doesn't matter right now. In general, if these Sevians are congruent, let us say they meet at point P. If these Sevians are congruent, we have Vx by xc multiplied by Cy by Ya multiplied by Az by Zb equal to 1. The product of the segments formed by the segments, in fact, the product of the ratios of the segments of the sides of the triangle is always 1. This theorem is known as Sever's theorem. Right? Now you know how it will help to prove the congruence. There is a converse for this. If this ratio is satisfied, they will be congruent. Right now, what I am saying, if they are congruent, this ratio is satisfied. What is converse? If this ratio is satisfied, they will be congruent. That is the one which actually we use to prove those altitudes are congruent. Isn't it? Right. Now our theorem has come. So what next? We need to prove it. We need to prove it. Today we will not prove too many theorems, but one or two theorems we will prove. One of this. We need to prove this. So how to prove it? Let me take the area of ABX. So straight away you are starting the area of this. How do you get that idea? How do you know you need to start with this? That's the normal question that comes in geometry. I will explain little later what is the rationale behind starting with this. Let me start with that. ABX half into base into height. I take a height, imaginary height, x. Okay. Height is you are drawing from A perpendicular to BC. That becomes the height. Now take the area of ACX half into CX into height again. Right? Huh? This is a symbol for area. Many books and many authors use this kind of notation to tell area of the figure. Right? So what is next logical step? Divide. Very good. What is the idea behind that? Somewhere we are looking for this ratio. So that pushes me to divide this. So let me say 1 divided by 2 gives me Bx by Cx equal to area of ABX by area of ACX. Is it clear? We got the ratio in terms of areas. Now, let me get these two triangles and again get this ratio in terms of these two. So, what is area of PBX? Half into BX into H. Area of PCX half into CX into H. So BX by CX again area of PBX by area of PCX. So combining these two results, we have Bx by Cx equal to ABX by BCX equal to PBX by PCX. Right? Now, from this result we can write as Bx by Cx equal to ABX minus PBX by BCX minus, there is some, should be ACX now. ACX minus BCX. Do you know this result? result I am using here? Dividendo. Dividendo. I'll give an example. This is simple result. Suppose you have, let us say, 10 by 30 equal to 1 by 3. Right? This can be same as 10 minus 1 by 30 minus 3. Or, yeah, I'm using similar result. You can check that the ratio holds. Okay, right. I'm using it. So, Bx by Cx equal to ABx minus PBx will be how much? ABB by ACx minus PCx. ACx minus PCx. Yeah. ABC. I will call it as P. So we got this ratio Bx by Xc. Is it clear till now? Now next I try to find this ratio. Cy by Ya. I will not do all the steps. It recurs na similar steps. Can you tell direct answer? Very good. Area of APB by area of CPB. This triangle area by this triangle area will be. I should write reverse now. Cy I am writing here. CPB, APB, right? Yeah. What is the other ratio we need to find? Left over. AZ by ZB. AZ by ZB. How much? Can anyone try? APC by BPC. APC by BPC. The round is set. Now simple. Take the products. Px by Cx multiplied by Cy by Ya multiplied by Az by Zb equal to area of APB by APC CPB by APB APC by BPC. We have APC here and APC, APB, CPB, BPC. Let's move. Okay. They can come from go ahead, children. You can make quick notes. Like, who are smart children, no need of writing regular school notes like. Yes. Now, the next part comes the converse of this thing. Before that, can you make out why did we start with these areas? What was the reason behind it? See, when we are doing maths, someone tells do like this. We do it. And we are successful at school. But when we think of some competitive exams like Olympiads or JEE, etc., there no one will tell you what to do. You need to start somewhere with something. But starting randomly will not take you where you want to go. Some reason should be there. You should be foreseeing 3 to 4 steps ahead. If you feel it works, you should start. After 4 steps, if you are imagining it won't work, you should stop. That's it. Can anyone explain what was the reason, logic behind this?
Sir, if we change the point P, the property might be changed.
Ah,
But sir, I can see that the area property of area is
good. That is one way of understanding that. What he says, if you change the P position, the angles and other segments may change, but the areas will remain same because height will be remaining same. Like suppose you take P here, Bx by X remains same. So Bx by X we need the ratio, and height remains same. Correct. So this ratio will be maintained wherever you take. That is one reason. And most fundamental reason, we needed these ratios in the picture. Right? To prove this statement, we need the ratios. So where do I get these ratios from? Either it should be from congruency, or similarity, or areas. Right? I discarded congruency and similarity. The reason nothing is fixed here because we can change the location. So the option I had was areas. How many of you understood what I am trying to say? Good. So like some reason should be there when we start that. Isn't it? Next. Converse of Sever's theorem. Converse of Sever's theorem. So let us go fast. Oral answer will do for this. Converse क्या होगा? The figure will be same. If this ratio is maintained, they will be congruent. So A, B, C, and AX, BY, CZ are the segments. We have the ratio Bx by Xc equal to Cy by Ya equal to Az by Zb equal to 1. If this is maintained, they will be congruent. So how to prove this statement? We can prove this by indirect method. So what is indirect method? Let us suppose they are not congruent. Right? Suppose they are not congruent. Now what will happen? By and Cz will be anyway, they will be passing through one point. Let us suppose Ax doesn't pass through P. Let Ax does not pass through P. If it is not passing through P, somewhere we should have X dash. Ax dash should be passing through P. Right? Do you get this? If Ax is not passing through P, there has to be one segment not passing through P. Let us suppose that is Ax dash. Now for this, let us apply Sever's theorem. Bx dash by x dash c equal to into Cy by Ya into Az by Zb equal to 1. We have this result by using Sever's theorem. And the given result is this. And we got this. From these two I can conclude Bx by Xc equal to Bx dash by X dash. What does this mean? This is possible only when X and X dash coincide. So this X dash should come back to this. making them congruent, sorry, concurrent. This completes the proof. You got this? Yeah. So make a brief note. So have you got the proof? How many of you understood the converse part? I was very brief there. Good. Now, yeah. This is converse part. Yeah. This step. So from these two results, we are getting bx by x equal to bx dash by x dash c. So take these ratios. This by this equal to this by this. The ratios are equal. When it will be possible? Only when these two are equal. Then only it is possible. 10 plus children. Have you used this kind of approach anywhere? Very good. You must be familiar. When you are doing converse of PPT, you use it, right?
Yes.
Huh? Yes, one more place. 9th class children also use it. Right? It is in 9th class. It is in 10th only. 10th class only. Triangles. So two places we use this kind of approach. Okay. So this is the theorem. Now let us use this subject. Right? So where shall we use? We can go back to the basic first question. Altitudes of a triangle are concurrent. So let us try to prove that by using Seva's theorem. Right. That is the next question. Prove that altitudes of a triangle are concurrent. Prove that altitudes of a triangle are concurrent. So we take the triangle ABC. AD, it is a Sevian and also altitude. Altitude means perpendicular to opposite side. E, CF, right? So we need to prove that they are concurrent. Huh? They will pass through same point P. We will not depend much with this. So why to unnecessarily? Okay. Normally, I give some time to react for you because of the nature of the lecture. Let us try getting to the proof straight away. Some places I will give time for you to think and respond. Some places we do directly. I will give the answer. You try to grasp. Right. So we want to prove these are concurrent. Right. If I can prove that BD by DC multiplied by CE by EA multiplied by AF by FB equal to 1. If I can prove that, I can conclude AD, PE, CF are concurrent. That makes sense by using converse of velocity, right? So now my thought process or working will be to prove these ratios, the product of these ratios equal to 1. Now, here I have some flexibility. Because they say altitudes, DEF are fixed. And I want the ratios of the sides. So my natural choice will be either similarity or congruence. So similarity is more general, right? So we go for similarity. So choose certain triangles, prove that they are similar, get the ratios, and prove the product is 1. Okay, right. So I'll start with, I want to get these ratios basically, right? AEB and AFC. In triangle AEB and triangle AFC. Why did I start with this? These are the two triangles that give me this ratio. I'm thinking of proving similarity. If I prove similar, I will get in the picture. AE by AF, which is needed something. Correct? I consider these two triangles. We have angle A equal to angle A. To be precise, EAB equal to FAC. Right? They are common. This is common angle. I need one more. We have 90 degrees. Angle AEB equal to angle AFB. Each 90 degrees. AFC. You are right. Thank you. So triangle AEB is similar to triangle AFC, isn't it? Why? What similarity it is? A similarity. Is there anyone here children who don't know about the similarity? Congruence, all of you will be knowing. Similarity comes in 10th standard. All of you are having basic idea. If you can recognize this is A similarity, that is done. We don't need more than that. Right. So we have AE by AB equal to AF by AC. Corresponding sides of similar triangles. They are proportional. Take it as relation 1. What is my next choice of triangles? Yeah. Can you come again? BFC and BEA. You are talking about BFC and BDA. Who is saying this? Yeah. So she is focusing these two ratios now. That's why she is taking these two triangles. BFC, BDA. So triangle BFC similar to triangle BDA by A similarity. Escape distance. So from this we have BF by BD equal to BC by BA. What is next set of triangles? Target these two ratios. CEB and CDA. Triangle CEB similar to triangle CDA, again by A similarity. So we have CE by CD equal to CB by CA. So whatever we were looking for, the ratios, all the terms are appearing on the left side. If I do this, will I get this? Check it. At least left side terms. AE, no, right side terms I need to check. AF by FC. AF is there. AC. No, we don't have, right? I can rewrite this result.
E by EB cross by
AE by AF equal to AB by AC. Here I think I wrote correctly. Now check the left sides. AE we require here. AF needed. DF here is there. DF by BD. BD here. CE we have the term. CD we have the term. But multiply it. AE by AF multiplied by BF by BD, CE by CD equal to
1.
AB by AC, BC by BA, CB by CA. There's little problem, right? They're not cancelling. These two are getting cancelled, but these are down. They both don't cancel. Right? So we have to reciprocate. CA by CB. This also. CD by CD. 1. Now check these ratios. Let me put this in order. DC by BD. I'm taking this and this here. Next, EA by CE. I took these two terms. Next, AF by FP. Just reverse this. DD by DC, CA by AA, AF by BA. So this ratio we are getting equal to 1. So I need to do one connection. This has to be what? Right. Implies AD, B, CFR, concurrent. Okay. Sega's theorem, converse, and one application. Next. We'll move on to next topic. That is the collinearity.
Like in writing ABB, B equal to C cos A, BC equal to A cos C.
Right.
Then
You are telling alternatives, right? By using trigonometric equations. It can be done. This is one possible proof, and this is not the only proof, right? We have different approaches. And here we are specifically using Seva's theorem. Okay. The next topic we move on. What it is a collinear. When do we say 3 points are collinear?
But they are of the same.
Very good, as simple as that. When 3 points lie on the same line, we say they are collinear. Now, I have 3 points. Now, I push you to think it various methods. Let us see how many we get. See, I have 3 points. Let us say ABC. Okay. They are collinear. They are lying on the same line. I want to prove they are collinear. How to prove it?
When the distance of AC is equal to
Ah.
distance of AB plus
Very good. If you get the result, AB plus BC equal to AC, they are collinear. Any other way? Good. So there is one more way. Area of ABC 0. If you prove that, it confirms that collinear. Any other way? Very good. If you can prove that slope of AB equal to slope of AC, then collinear. Now what is slope? Don't worry about it. You will learn in higher class. Many of you know it. The idea here is we should not have various ways. That's the point. Any other way? No.
ABC equal
If you can prove that angle ABC 180 degrees, again it makes the collinear. Any other way? Okay. Any other way? I'm just checking what level you can go. How much you can do. Anything we can do by using vectors? Anyone? No? If I can prove that vector AB is lambda times of vector AC. Okay. That will confirm their collinear. Huh? Or I should take BC, then it will be no other. Any other way? Yes. You are defining collinear. Right. So the point what I am trying to say, if you want to prove 3 points are collinear, you have various ways. Depending on the situation. If you know the lengths, you will use this. If you know the slopes, you will use this. To find the slopes, we need coordinates of ABC. Right? And if you do not know the coordinates of ABC, you can even find the area. There are various ways.
there is not a certain data that is fast.
Very good. Very good. Another way of looking at it is you prove that there is no circle passing through all the 3 points. It is impossible to have a circle which passes through ABC. Right? That also confirms collinearity. Good. I learned new thing today. I got a new idea. Okay. Right. That's the reason I am pushing you. Yes. By using vectors, again angles. In the same way, we have one more way to prove the collinearity based on some other information. That method is known as Menela's theorem. The next topic is Menelaus theorem. Menelaus theorem. This basically deals with the collinearity of points. So if we have so many methods to prove collinearity, why do we need one more? That's how we get that. If I want to go from Amshaktinagar to CST, I must start with an ending point. I should know what are available to me so that I pick up the right one, which will take me in time safely. Similarly, when you are proving some result, you know starting point and you know ending point. How much, what you have with you, you know. What you need to get, you know. You should also know what are the available ways so that you can pick up the right approach, right? That's the reason we should have work. So, one of the methods is Menelaus theorem. What is this theorem? Suppose I have a triangle ABC and a transversal cuts the side at P and Q, and it doesn't cut AB internally. Whereas, if I can extend, let us say it cuts at R. It is cutting, right? So, in a triangle, PQ is a transversal that cuts BC at P, AC at Q, and AB at R externally. Right? In this case, we have BP by PC multiplied by CQ by QA multiplied by AR by RB. They are following one cyclic order. If you observe, we are not writing it randomly. This by this, I'm starting with vertex P. I'm starting with vertex P. BC is cut by P, so BP by PC. Then vertex C, CQ by QA. Then vertex A. Where is the cut? Here. AR by RB. This product is equal to -1. This is known as Menelaus theorem. What is this importance of this -1? This shows that these lines are directed. What does it mean? When we are working with segments like congruence and all those things, BR or RB chalega, both will do. Whether I have BR or RB, it works for it as a length. But when we say directed line, BR and RB are different. If I take BR as positive, RB will be negative. So, where the lines are directed, where the lines are directed lines. If I write PP by PC, CQ by QA, AR by BR, I can say what? Isn't it? RB go na BR. So one negative will come. At this stage, because we would deal only lengths, you can ignore this negative sign comfortably. You can change the order whatever you want. RBR, BR you can take, no problem. Ignoring the negative sign in Menelaus. Okay. Right. Have you got this? No. Here, P and Q are cutting like this. What if the transversal cuts all the three sides externally? What I am trying to say, I have a triangle ABC. I have a transversal like this. Will the Menelaus theorem work? First of all, are you convinced this cuts the sides AB, BC, and AC? Are you convinced? This is where we need to push one step level ahead. They intersect. We don't see physically because it is external intersection, right? So, if I think I have to draw slightly better diagram to make them. I go reverse. I extend this, I extend this, I extend this. I need a line that cuts all the three now. To get the diagram, I went reverse first. Now, let us suppose BC is intersected at P, AC is intersected at Q, AB is intersected at R, external. Still Menelaus theorem works. Okay, it looks nice. There is a triangle, you take line somewhere outside. Still you can get the. Can you write Menelaus theorem for this? Right?
QC by CA.
One, yes. Right. So start with one vertex, go in one particular vertex. So if anyone has written, raise one. I will write that you have written. Now let me write it. I start with vertex B. Where is it intersected? R to B. I like this angle. BC is intersected at P. So I write BP by BC. जहाँ intersect होते वहां तक जाओ. Where it is intersecting, go till there. Then come back. Multiplied by. Then go to the vertex C. Where it is getting intersected, CA is intersected at Q. So CQ by QA. Then go to the vertex A. Where AB is intersected at R. AR by RB equal to negative. 4 children wrote this before I go. How many of you got it right? Good. 1, 2, 3, 6. Nice. You were able to grasp that. It's simple only. Just maintain that scientific order and the concentration. And where it is cutting, we stop one minute. Go till there, then come back. Now, we stated Menelaus theorem and we need to prove it. Okay. Let us try to prove this. of Menelaus theorem. I promise you it is simple proof, don't worry. Normally proofs means we get little tension, right? This will be simple. Keep your mind open. So we take triangle ABC and I take the transversal that cuts this way. Let us suppose it cuts BC at P, AC at Q, AB at R. AQ by this one. We are going to vertex C. CQ by AQ. Because this vertex here we have taken this side. Here by R. We did. If I take this side, I should not take this side again. Because for A, if I take this side again, this will be left out. For BC, I took from B. For CA, I took from C. For AB, I took from U. Or we should have same diagram in a different the transversal I took it here just for ease of looking at the diagram. So ABC, this is the transversal. BC is cut at P. AB is intersected at R. CA is intersected at Q. Okay. What we need to prove? BP by BC multiplied by CQ by QA multiplied by AR by RB equal to 1 or negative 1. We are ignoring that negative. We need to get this result. Again, I need the ratios. Proving congruence similarity looks a bit out of the way. At least congruence we can rule out. Similarity looks possible. There are some triangles we can see. We use developed version of similarity. That is BP. Right. So we do a construction. Draw AK parallel to PQ or Q such that K lies on BC. Right. Now, take the triangle BKA or BAK. These two are parallel by construction, so I can use GPT straight away. PR by RA equal to BP by BK by using GPT. All of you know basic proportionality theorem, like the main system. You are available. Anyone don't know? I will give the concept. GPT don't know. Anyone else? Okay. Because we are going to use again and again. Take this triangle ABC. Let us say PQ parallel to BC. in a triangle PQ parallel to BC, we have the result AB by PB equal to AQ by QC. This is called BPT. In a triangle, if a line is parallel to third side, in a triangle, if a line is parallel to third side, it divides the other two sides in the equal ratio. Then there are some corollaries of BPT. Sorry. We have some more results which will follow from this basic results. What are those? I can say AB by AB equal to AQ by QC. Sorry, AQ by AC. This is called corollary of BPT. This is a result that follows from this. BPT is this by this equal to this by this. Corollary what I am speaking. This by total equal to this by total. There is one more. What is that? AB by AB equal to AQ by AC equal to even this by this. DQ by DC. This by total equal to this by this. This also comes from BPT. These are corollaries. Today we are going to depend much on this. This is clear. Have you got this result? 1.2. Just remember this result. Right. So we use the same result here. Okay. Next step. Take this triangle CQB. Again we have this is parallel to this. We can use BPT something like CA by AQ equal to CK by AQ. But will it work for me? Why this won't work? Because I am getting a term which is not there, what I want. So I will not directly use BPT. Out of these two versions, which one will be handy? CA upon CQ equal to CK upon CA upon CQ equal to what did you say?
PQ upon AQ equal to PC by P. Then PK will get cancelled out.
CA upon AQ equal to CQ upon AQ equal to CP na? CP upon this one PK. It is none of this. We have one more. So we have one more result from BPT. What is that? AB by PB equal to AC by BC. Right? You are using this. Why did we change from this to this? Because our eye is on this. We want to get these ratios. Now, take it as 2. 1 divided by 2 or 1 multiplied by reciprocal of certain equation will give me PR by RA multiplied by AQ by CQ I should take reciprocal of this equal to P3 by PK into the reciprocal. PK by CP. They get cancelled. So PR by RA, AQ by QC, this is sent here. CP by PP equal to 1. Is it Menela's theorem? We have this term here, QA by CQ. This term here, this term, but in the reciprocal way. So I can now reciprocate RA by BR, QC by AQ, PP by CP. This is the proof. Negative one. You can ignore that negative one. It is because of directed lines. When I am taking the ratios, I am not seeing whether I am taking PK or KP. I have freely used. By knowing that, I will ignore this negative sign. If I am particular with the direction of the line, then the negative sign will come. At this stage, no need to consider that. Because mostly we work on the lengths, we take in any order, A, B, or B, A. Good point. Noted, children. Okay. Now theorems are done. So new learning is done. Now whatever we learned now, whatever we learned before, we will try to apply. We take up the application of this Menela's theorem. To save time, we have the questions in our hand and we start attempting. Then pass on. Take one each and pass on. Take one and pass on. One each. Going crazy. How your reaction? All of you got this, children? Raise your hands. First done. So take some 2 minutes break. Just reflect what we have learned today. Just browse back, recall the things. Then we start the problem. 2 minutes time you can take to refresh. Drink some water. Fresh mind. Shall we start? Some of you are already looking into questions. I like it. If you are very interested. Uh, First one we have done already. There was theorem application we have done. The second question is related to Menela's theorem application. So let us try that. First of all, see whenever next 7 questions when we are attempting, we follow some approach. Then I tell you to read the question and draw the diagram. Draw the diagram and show me. Because drawing the diagram is one of the key step in geometry. Then we can start solving. So take up the second one. Try to draw the diagram. If anyone has drawn diagram, just leave the book and show. Yeah, that diagram is right. Anyone? Right. Only that ratio is not maintained. Something is 2 parts, something is 1 part. Right? Diagram is right. 3 children got that diagram. No, I'll get back to that. That's right. Okay. So what is given here? In triangle ABC, AB equal to AC. So we have triangle ABC, AB equal to AC. A transversal cuts AB, AC, BC at KLM respectively. At AB, it cuts at K, AC at L, and BC at M. So how does it cut BC at M? Because K is here, L is here. Transversal बोलती है KL line पे जाना है. So it is understood that now it is external. Except M. Right? This is the diagram. How many of you got it right? That's good. So what is given here? Given AB equal to AC and KL equal to 2LN. The diagram became bad. They say KL is 2LN. This has to be twice of this. The diagram don't speak. But ignore that. It is not to the scale. Okay. Right. But remember this result. What we need to find KB by LC. KB by LC. See, now I told we have this Menela's theorem application. So you start using Menela's theorem. But if you sit isolated in an examination, how do you get this idea? It is Menela's theorem. Any linking concepts or words? Very good. They are talking about a triangle. Transversal is cutting. These are the links to go for Menela's theorem. And ratios are involved. Huh? Answer, he is ready with the answer. It is correct. Very good. Okay. So by applying Menela's theorem, by using Menela's theorem, but where? Should I use for ABC or should I use for some other triangle? Again, key factor. My natural choice is ABC. But if you write that ratio, you will realize it won't work. What is the reason? Given information. As simple as that. If you take triangle ABC and start writing Menela's theorem, it is right, but it will not help you because of this given information. As per the given information, we need to take some other triangle here to use Menela's theorem. What is the triangle? Why? How do you get that idea? What is the triangle? AK KBM. You can check it later on. It may not work. You can take
AKL.
AKL. AKL. Take the triangle AKL, and what is the transversal here? Huh? One said the BM should be the transversal. Any other? So BM works. Yeah. You got the answer. No? BM works.
So what I get as a
Okay. So try with BM. Again, go systematically. Select one vertex. Start with that. Okay. Children, you know Menela's theorem statement. Okay, just check this. How many of you got same? One, two, yeah, good. So what I am doing, just those who are not getting, I am choosing vertex K, triangle AKL, vertex K. So choose the side AK. AK is cut at B. So I am writing KB by BA. Then go to vertex A. AL is cut at C. So what do I have? AC by CL. Then go to vertex L. LK is cut at M. So LM by MK equal to -1. Right? Now, PA and AC cancel out. Why? Given they are equal. Under KB LC. KB by CL, we need to find. So no need to touch this. LM by MK. If I take LM as X, this will become 2x, right? As per the given information. KL equal to LM, na? So take this as X, it becomes 2x. So LM is x. How much is mk? Mk should be 3x equal to -1. So Kb by Cl equal to -3. So what is the meaning of this negative? It is just directed line. Cl को Lc बन, it will become plus 3. Kb by Lc equal to 3. That is the answer. And we got it.
So can you explain how to write those ratios and
How to write the ratios in Menela's theorem? Isn't it? First of all, locate the triangle. Which triangle you will apply Menela's theorem? Step 1. Step 2, locate the transversal and get the idea where it is cutting. Sometimes internal cut, that means on the segment. Sometimes external cut, outside. Third step, choose one vertex and imagine that side. From the vertex, go up to the cut and come back to the next vertex. I'll explain. First step, I chose a triangle AKL. Second step, I chose a transversal. Third step, I targeted vertex K. Then I am focusing on the side AK. I can choose side KL also, no problem. It's not restriction. Why you should take AK only? AB lesson. I chose AK. Now where this AK is cut at B. So starting from K, KB by BA. A vertex okay. Come to vertex L. Now which side I should choose now? I should not choose this. I should choose this because I am going in this order. So vertex L. Where this L is cut? M. LM by MK. Next choose vertex A. Now which side I should choose? Not this. Yeah, already okay. This. Where this AL is cut at C. So A to C, C to L. Got it? Right. So now let us attempt third question. Question number 3. Try. Try means read the question, plot the diagram. Which theorem shall we apply here? Again, not direct Menela's theorem, but somewhere we use it. But let me question first try the question. Very good. Your diagram is right. No, not right. Diagram is right. They are talking about one area of triangle na, वो area को shade that area. I'll make it. Very small. You can yeah, it's not the scale. No, not right. Which one? Correct. So area को shade. No, not right. No. It is too small. I can make out something. Is triangle made here? No. Made triangle here. Yeah, over that. Correct. Okay. No, not right. No, not right. Okay, I think some 7-8 children got. Now let me try my turn. On the sides BC, CA, AB of triangle ABC, DEF are taken such that BD by DC, CE by EA, AF by FB equal to 2 by 1. So there is a triangle ABC. Isn't it? Now, just pay attention. There is triangle ABC. P is chosen on BC such that BD by DC equal to 2 by 1. BD by DC equal to 2 by 1. Two parts, one part. And also, E is chosen on CA such that CE by EA equal to 2 by 1. Two parts, one part. F is chosen on AB such that AF by FP is 2 by 1. If you located these ratios correctly, you are almost to it. Now, some children, what they did, the moment they got 3 points, they joined it. They got the temptation to join. Because that's what we did in the school. But again, the triangle formed by the lines AD, BE, CF. So they talked about line AD, join AD, BE, join BE, CF, join CF. The triangle formed by these lines. Where is the triangle? This is a triangle. How many of you got this right? This diagram. Good. More than half. Nice. What is the question? We have to prove that this area, let us say it is the PQR. I want to use same symbols. PQR. To prove area of PQR equal to 1 by 7 of area of ABC. Okay. So let's go with this. I saw someone got this answer. Someone. But you are on the way. Okay. So then just to save time, I will start. Okay. Later on, you can see the thought process because we have limited time. Otherwise, I would have given you time to respond. So let us start doing this. Area of ABD by area of ADC, how much? Can anyone say? Huh? Very good. It has to be 2 by 1. There are no similar triangles here. What you are telling is very similar triangles. It is 2 by 1. How I tell you? This you take for granted. You have a triangle ABC. Isn't it? This is very nice thing. Let us say this is P. What is ratio of areas of these two triangles? BP by PC. How does it work? You have a common height h. Area इनका क्या होगा? Half into base into height. What is this area? Half into base into height. Same height. So if you find ratios, half of will go. Height h will go. This BP by PC only will come. In a triangle, the CBL divides into two areas. The ratio is equal to area of the sides, segments. Area of this by this equal to this side by this side. That's what I'm saying. That is how your median works. Median में क्या होगा? This becomes midpoint. The ratio 1:1 बनेगा. So that's why these two areas become equal. This by this equal. That is special case of this gender one. Have you got this? Yeah. So from this we can write this is 2 by 1. So area of ABC equal to AB. How many times? Half times. Suppose I want to write this as ABC. Then how many times? Very good. 1 by 3. So let me call it as delta by 3, where area of ABC I will take it as delta, just for simplicity. So area of ADC is delta by 3. Now I want the ratio AR by RD, because I want to compare this area and this triangle area. Later you will understand why. So take the triangle ABD. In triangle ABD, take the transversal CF. By Menela's theorem, take this triangle, take this transversal, try to apply Menela's theorem. AR by RD. I start with the vertex A. I am going this way. AD is cut at R. So AR by RD equal to what is next ratio? I should target B, sorry, vertex B. BD is the side. It is cut at C. DC by CB. What is next? Vertex B. DA is cut at F. BF by FA equal to 1. Ignoring the negative sign. We are not focusing on direction of the line. Just take a minute, go through this. How we write this. Right? Now, AR by RD multiplied by how much is DC by CB? Very good. You said 1 by 3. Because this is 2 parts, this is 1 part. As per the given information. So DC by CB, 1 part by total 3 parts. How much is BF by FA? Yes, you are right. Say loudly. 1 by 2 equal to 1. So AR by RD equal to 6. Correct? So AR equal to 6 RD or RD equal to 1 by 6 AR. Right. So what is area of CRD? Area of CRD is how much? 1 by 6
of babies.
ARC. Correct? Because this by this is 6 by 1. So ratio this by this also should be 6 by 1. That's what we wrote here. So what next? This area is 6 times of this. That's what we are getting. Correct. Now what about this area in terms of ADC?
Yes, sir.
1 by 7. Therefore, area of ARC equal to 1 by 7 of
Yes,
ADC.
6 by 7.
6 by 7. Because this is bigger. Is this clear? Now, what is area of ADC in terms of ABC here? 6 by 7 into delta by 3. 2 by 7 delta. So what I am getting here is area of ABC, so ARC is 2 by 7 times of ABC. That's what I am getting. To get this, I wanted this ratio. To get that, I wanted this ratio. To get that, I used Menelaus. Take a minute, reflect on that. Now, what is area of BQC? How much? By following the similar steps. It has to be 2 by 7 delta. What is area of APB? APB 2 by 7 delta. These two follow from this one. How we got here? Same thing. So, in color chart is black. This area, this area, this area. Those three triangles I am talking about. This 2 by 7 of total, this 2 by 7 of total, this 2 by 7. Now I know this, how to get this middle one. From total area, subtract all the three. So, area of PQR equal to total area is delta, 2 by 7 delta, 2 by 7 delta. One by 7 ABC. That's what we do. Just erase. of you understood this? Yes, very good. Number. I will just outline what we have done. Just one more time, the thought process. See, we wanted to find this area in terms of total. So my original idea was from the total, subtract this area, this area, this area. You will get this. Now I wanted to find this area in terms of total. So first I found this area in terms of ABC. Then ABC connected to total. I repeat, ARC I found in terms of ABC. Then there I connected ABC to ABC. How ABC and ABC are connected? Because of this ratio. That there was connection in areas. How these two areas are connected? Because of this ratio. This ratio though they have given. We used it. But this ratio they didn't give. We used it by using Menela's theorem. Now go through this one more time. Perhaps this may be R&O level. Easiest question of R&O. You can put it that way. Shall we move on? Take up the next one. This you may enjoy more. Take up the fourth one. ABCD is a parallelogram. Longer side is twice the shorter side. XYZW is a quadrilateral formed by internal bisectors of ABCD. If the area of XYZW is 10, find the area of ABCD. That is a possible diagram, but that is not right because it does not conform bisector. It's a parallelogram. You know that. Answer is 40. You are getting 40. See children, here there is a, I will tell you, ABCD is a parallelogram. ABCD. This is 2x, this is x. Let me go by scale, taking note by scale. See children, here. In fact, many of you, all of you, what you are doing, the moment you see angle bisectors, you started drawing this. Right? And you are getting some figure here. Here the catch is, there is no guarantee here the angle bisectors will form this here. Because this may not be angle bisectors only. So in the first step only we should have some solid step where the angle bisectors meet. Okay, for that we will have slightly different approach. See what I am doing. Once I do this, this becomes simple. I take the midpoint of AB as x, midpoint of CD as z. Why am I choosing this? Because somewhere in my mind I know I am going to get the diagonal here, x, y, z, and I join these two. AXZD is a rhombus. How to justify? Good. It is already parallelogram because this will be x, this will be x. Opposite sides are equal. and they are parallel. So it became parallelogram. And adjacent sides are equal now. It became rhombus. Is it clear? ABCD is a rhombus. So if I draw diagonal AZ, this is the angle bisector. Because in a rhombus, the diagonal bisects the angle. And where most of we were going wrong in the beginning, we draw angle bisector, but we stop somewhere here, saying that it will. Here the hidden part is the angle bisectors actually meet here. Now draw dx. This is angle bisector of this. Similarly, XBCZ is a rhombus again. If you draw diagonals, they are the ones angle bisectors. This is the one which is going to form the XYZW coordinate. It is essential that X and Z should lie on the sides of the virtual parallelogram. Because of this ratio, 2x is here, x is here. If they are meeting somewhere in the middle, our diagram will not be right. How many of you understood this? Good. Now it becomes a little simple. Area of XYZW is 10. How much is this area? 5. How? You know, we can't take for granted. It looks like a half, but how?
The diagonal of a parallelogram divided into two
Very good. Diagonal of a parallelogram divided into two parts. But how do you know it is parallelogram? XYZW. But this is not angle bisectors of parallelogram. Okay. You are using the direct property. There is a property of parallelogram. The angle bisectors, they make parallelogram.
Actually, it's a rectangle.
It is more specifically if you see it is a rectangle. That is the next point. I want to justify XYZW is a rectangle. How to justify it? Okay. Diagonals of rhombus bisect each other 90 degrees. Very good. These two became 90. Does it confirm it is rectangle? No. Take our angle. One more angle at least.
Diagonals bisect. The diagonals of the rhombus are angle BXY and Y and Z.
Very good. Okay. I think now you are getting it. See children. If this is A, how much is this? A. If this is B, how much is this? B. How much is 2A plus 2B? 180. This plus this 180. Co-inferior angles. So this makes A plus B 90. How much is this angle? Very good. How much is this angle? B. A plus B is 90. How much is this? This is easy. Okay, we got 90 here some other way. And you give direct answer. Rhombus diagonals. Then how to prove this is 90? How much is this angle? A. Right? Parallel lines, transversal. A plus B 90 again. So we are able to prove this is 90, this is 90, this is 90, this is 90. So XYZ becomes rectangle. Right? Always we can't take for granted. Now if this is rectangle, this is diagonal divides into two equal areas. 5, 5. Then how much is this? 5. Why so? Either you use the property for congruent triangles or this is the midpoint in this triangle. So median equal areas. So how much is this? So what is the Area of XYZ double 8 into 5. Take a brief note.
That's why the diagram was wrong. Because the flight is directly to and then the area of flight.
Yeah, correct. Only which were luckily it is correct. Diagrammatically it is not. That is not right. Okay. Now question 5. Can you explain that? Which part? This one? No, like there were steps, no? This was rhombus, this was rectangle, then all the areas. Which part you are asking? Okay. How much time do you have? Then you can skip fifth one. Sixth one you can try. Sixth one. Because there is one answer where you can there. Try sixth one. First you draw the diagram, then show me. Got the diagram? No, we are doing sixth one. Because of lack of time. Sixth one. Sixth one diagram. Correct. Proving okay. Is it the diagram or the work? Diagram? Yeah, diagram is right. Right. Two circles touch each other internally at a point P. There is a circle, there is a point P. Is touching here again. At point P. You can draw better diagram. A chord AB of bigger circle intersects other circle at C and D. There is a chord AB for the bigger circle. It intersects smaller circle at C and D. Prove that angle CPA equal to DPB. Angle CPA. Don't disclose that. Others, let others think. CPA equal to DPB. These two angles we have to show equal, right? How many of you got diagram correct? Good, nice. Less number, but nice. Okay, shall I show the proof? Someone got already. One child got, I saw. Okay. See, what I do, I take a tangent through P. Okay, I call it as TS, tangent TS. Now, angle VPS equal to angle BAP. Why is equal?
Alternate side.
First of all, locate where those angles are. PPS, PAP. I am saying these two angles are equal. We are taking PB as the chord of the bigger circle. This chord is making this angle with the tangent, and this angle is made in the other segment of the circle. So these two are equal. So we take PB is the chord, and alternate segment theorem. We are using that. Similarly, angle DPS equal to angle CDP. Why? Now, in the smaller circle, take DP as the chord. So, DPS, angle between chord and tangent, is equal to remaining part of the circle. PD is the chord. Na? So, DCP. DCP. So, here PD is the chord. Now, subtract 1 from 2. 2 minus 1. Angle BPS minus angle BPS equal to angle DCP minus angle BAP. How much is this? DPS minus BPS will be DPP. Right? This is one of the terms which we want. Here I have to manipulate. Observe DCP. Where is that? DCP. Here. This angle is sum of these two. Why? Exterior angle property. So, angle CPA plus angle CAP minus angle BAP in this term. These two are same. Angle DPB equal to angle CPA. Understood? How many of you understood this? So there are two more questions, in fact 3 questions. One is too simple. Remaining 2, they're good ones. Right. If time permits in future, we will try sometime. So meanwhile, you can try yourself. If you are genuinely trying, I will help you with the solution. So what we have done today, let us summarize. We just recalled some concepts of quadrilateral circles. Two main theorems: British flag theorem, alternate segment theorem. Then we saw something about tangent. Then Sever's theorem to prove convergence, Menela's theorem to prove collinearity, and one application each. And both the theorems we prove. Then some questions based on quadrilaterals and circles. Okay. Right. So we will end this session here. Okay. Thank you for good participation.
So, at the end of the section, I would like to thank Sudhakar sir for giving us the precious time and help us to understand this topic. Thank you, sir.
We will meet one more time. If anyone tries these 2 questions, and if you want to help, that time we can spend some time on this. Okay.
Students now already can go for a 15-minute break. After coming back, you will be circulating a sheet
on correction of their names if any. So English name, Hindi name, both you have to check properly and that you have to write. Okay, so the certificates will be printed with that name only. So please see to it that you are now. Okay, now you can proceed further way. Come back. Yes,
The areas we divided, total parts are seven. Seven parts will say at least six parts. ये क्रिया इसमें क्या A is cutting A ना ये log हो so you to take small cut okay okay L is cutting that AC AC then L M is cutting AC correct is right इसमें एक के ये ट्रायंगल भी when you are applying modules first कौन सा ट्रायंगल आपको ट्रांसवर्सल करना we are taking this as transverse ये भी ले सकते हैं ये साइड में आके ये then start from vertices ये के एल कोई वर्टेक्स ले सकते के वर्टेक्स so here a k is selected k na k से शुरू a b by b then what then you are coming to l यहाँ एक so side a you can take this also so al is cut at m l से शुरू करना है where it is cutting at m lm by m what next ये कट ये ले ये साइड तो हो गया ऑलरेडी ये ले so it is cutting at c ये से शुरू ये c by l ये c by जो वर्टेक्स है वहां से शुरू कर because what where we do here अभी ऐसे c यहां कट होते करके this by this will ये वर्टेक्स से शुरू किया ये वर्टेक्स से कट तक चल ए सी दूसरा वर्टेक्स ये है ना दूसरा वर्टेक्स एल है ये एल को कट किया ना ये से शुरू करके वहां तक कट के वहां जाना वहां से दूसरा वर्टेक्स actually I could not complete was the class they could understand and I was fast
When I could understand.
okay